Okay, so here we've got an interesting problem. We have a diagram here, and it shows a general parallelogram. So this is a parallelogram, and these are what the coordinates would be in a general form. Meaning you could fill in any values for these variables, and it would always make a parallelogram. There's one vertex at the origin, so this is placed pretty well for us, and one side along the x-axis. So that's this bottom side is along the x-axis. What are the coordinates of D, this midpoint, which is the intersection of the diagonals? And how do you know? Well, the thing that we know about the diagonals of a parallelogram is that they bisect each other. So these two will be congruent and these two will be congruent, which means that D is going to be exactly the midpoint of either one of these segments. So if we can find the midpoint of one of those segments, then we're in good shape. I think it'll be much easier to find the midpoint from O to B, because O is 0, 0, and then we'll be working with zeros. And you might be able to just kind of see this. If we go from O to B, it is 2a plus 2b for the x coordinate and 2c for the y coordinate. So going from O to D is going to be half of that. So in other words, it is going to be, the coordinates for D are going to be half of 2a plus 2b, so that's divided by 2, and it's also going to be half of 2c for the y coordinate. And those are nice coordinates to divide by 2 because they have 2's in them. So if you do 2a divided by 2b, you could, it might make sense to kind of undistribute that 2, or to remove a factor of 2. So think of that as 2 times a plus b divided by 2, and you can see that those 2's will cancel out, and these 2's will cancel out. So your final coordinates there for D will be a plus b for the x coordinate and c for the y coordinate. Now, that's just kind of looking at the picture and reasoning through it and thinking about what's going on, and also realizing that, hey, these had factors of 2 in these coordinates, so that would be easy to divide in half. But another way to think about it is to use the midpoint formula. So here's the midpoint formula. And kind of what we did here is we used the origin as one of our points. So basically, this became 0 and this became 0 because the coordinates of that point is 0, 0. And so all we had to do was just take this one and divide it by 2. So that was easy. We also could have plugged these coordinates in and found the midpoint of that other diagonal, and it would have worked as well. I'll let you try that if you'd like, and if you get this, you know you did it correctly. But there's another thing we can do when we have kind of generally named coordinates of a specific geometric figure, using what we know about the geometric figure, using those properties. So you always want to look back at your notes and say, hey, this is a parallelogram. What do I know about parallelograms? What formulas do I have that relate to those properties? That's kind of where you always want to start with these. All right, so now we have a different one for you to try. So you need to explain why the x-coordinate of B is the sum of 2a and 2b. Wait. Oh, hold on a second. Okay, there we go. So you actually need that picture from the last problem. So explain why the x-coordinate of B is the sum of 2a and 2b. So you have to tell me, there's a 2a here, there's a 2b here. Why is this 2b plus 2a? And then in part B, you have a trapezoid with the base at the center, with the base centered at the origin. Is the trapezoid isosceles? So make sure you know what an isosceles trapezoid is, and then use the information you're given here to say, is this an isosceles trapezoid? All right. So give that a shot, and then we got one more kind of problem we're going to look at before this lesson is through. See you in the next video.